Hello, everybody. Um, Welcome to the first SolidCAM webinar in this webinar series, where our main topic is SolidCAM Swiss type module and a solution how to support military multi-channel Swiss type machines. This is Daniel speaking, and before we just jump into a presentation, I would just like to say that developing this powerful module came as frequently asked question, and it was requested by our customers who actually didn't want to leave the environment of SolidWorks and Autodesk Inventor. So we also found as a big market potential and importance of developing it. It also had a great impact to existing military model in general. So I hope that this webinar would also help you to all of you who never heard about those machines before, and maybe you will, after this webinar, find it valuable and understand better what those machines are capable of and how it works with this powerful module. So I will start this webinar series with its fundamentals of this module and machines in general. So let's start with what we all need to know about those Swiss type machines. So within the first couple of minutes, I will just talk about the machines itself. So in literature, they are commonly known as precision automatic lathes, Swiss type lathes, Swiss start lathes. Also, very frequently, I see the Swiss turning centers, long turning centers, and so on. Yes. But in SolidCAM, we all call them Swiss type machines. They're not necessarily made in Switzerland. Okay, so this is what I'm pretty much frequently I'm getting those questions. Well, the concept of the Swiss type machines actually started in late 60s in Switzerland, but it is not generally like that machines are made there. Okay, so let's talk about the concept. Okay, in front of your screen, you can see pretty much standard approach of the mill turn machine, where in this case I represent one part where the bar is pretty long here, and it is pretty obvious that here the part it's not moving, it is just rotating, while the tool itself it's making the main movements in X and Z direction. And because of this thing, this fact, reflection, deflection, and vibration will happen in the beginning of the part. Yes. The Swiss type model, its concept, it's a bit different. As you can see here, I'll just move the mouse over here. This is the main elements of every Swiss type machine. It consists of the chucking collet here, or I also call it chucker, which actually holds the bar and move it along the Z-axis. In order to have better stability, on the high end of the pod, it used the guide bush in order to offer the guide bush purpose offers additional support to the stock material, and then the deflection and the vibration will basically be minimized. So this is the main concept that all Swiss type machines have if they use the guide bush. Let's talk about a little bit about Swiss type capabilities. Okay, so it is very important that you don't get the wrong impression that those machines can do everything now better. Actually, they have the limitations. Okay, the first thing is regarding to the dimensions of the part. First biggest advantage is that the length of the part in ratio together with the diameter bigger than 5 is possible. So the very long parts with a relatively small diameter can be only machined. Another disadvantage is, and the only disadvantage is that diameters can be only up to 42 mm in diameter. In practice, the Swiss type machines are used between 10 and 32 or 36 mm. It doesn't go beyond that or lower than that. There are cases, but it's very not frequent. Yes. Because of those capabilities, those machines are very nice to machine the parts that I just put them here on the screen, and they found very nice practical way to help the industry in medical, also hydraulic, firearms. You will see it very oftenly, or aerospace, automotive. Yes, so those are small pictures that I just put it over here, so you have better overview of what are the parts actually that you can machine with those machines. Yes. All right, a little bit about the kinematic itself. On these two pictures, let's talk a little bit on the left side. Also, you can see the same on the right side. The thing that I wanted to present here is that you see that these machines usually have the linear turrets that with all tools that are sorted in a linear way, as you can see. So there are turning tools, there are milling tools, drilling tools, in the radial direction, in axial direction. They can have also the B-axis and so on. They're all linearly sorted in order to minimize the cycle time. So this is the main idea. They have also the main spindle and back spindle. And what you can note on the right side, right picture, is that you can see here the two parts. The second part is pretty small, so you cannot see it on the back spindle over here. But basically, what I wanted to present here, that these machines always work on the main spindle and on the back spindle simultaneously. So the goal is to pretty much set the same machining time on both spindles in order to reduce to minimize the cycle time. Yes, so both spindles work, let's say, roughly equally same amount of time. Yes, so the software must be capable to define all the tools, to define all this kinematic, to be able to see the two targets, two stocks on the both spindles, and to minimize the cycle time. Yes. All right. One of my favorite pictures over here. I just tried to put what are the Swiss-type machines in one sentence, and I just say that the Swiss-type machining provides a cost-effective way to produce small, complex, and precision parts in large quantities. Okay. So on the back side, I just put really well-known on the market machines, pretty much standard mill turn machines with also two spindles, two turrets, and so on. Yes, and in front of those machines are the Swiss-type machines. Obviously, they are much smaller, and even if you somehow achieve to machine the same part on big machine, you will not be cost-effective as the one that are in front. Yes. All right. Let's talk about some most popular Swiss-type machine brands on the market. I didn't put them all. Okay. I just speaking with our partners in the countries and with our customers, we found that those are one of the frequently used that we can find at our customers. They're not all here, yes, but this is one of my favorite ones. Okay, right. So what are the main difficulties in Swiss-type machining? Okay, so the very first thing is that every single customer is fighting with is that every G code today that is generated on Swiss-type machine, it is done manually. Yes, so you can imagine how much issues it can be with that, human errors, you know, also always is problem with the drawing, then maybe drawing will be modified and the G code must be changed and so on and so on. So there are many rooms for the error. And this is one, I would say, the top common issue that every customer have on these machines. Yes. The second thing is there is no visual verification. So even though if you somehow manually program, there are pretty much also simple Swiss type machines on the market. There is, after you completely define your G code, at the end you have no visual verification. So you must run the machine single block, making sure that everything is going correct. The operator itself lose the connection, that he don't know what will really happen. Even if the program is made by him, then of course he's pretty experienced and he'll know in that case. But if we are talking about that somebody else is making the program and then giving to the operator, then there can be a lot of issues on that side. Yes. So definitely my third in this list, it's operator holds the knowledge. So the operators itself are very experienced persons who must know every G code and M code on this machine. They are manually programming these machines. They know exactly what machine is capable of, and this is very, very much problem. Just imagine if you are in the workshop with, let's say, 5 different machine brands, maybe different kinematic, and you cannot have only one person who can remember all those machines, M codes, and G codes. The best way is actually to store it in the CAM software, and you just need to select the machine and generate a G code for that, right? So this is one of the main problems, that the experience actually goes with the operator. Yes, so I found that the CAM, in this case, it's very, very much needed. And the fourth one, I would not say it's the less important. It's, I think, coming more and more these days, is that programming complex parts and advanced machines. So the G codes today on the Swiss type machines start to be bigger and bigger. Machines start to be more and more complex. I can see now going on the exhibitions and the big ones, and where you can find the Swiss type machines. I can see also not one but also 2 B-axis, 2, 3 revolvers, and so on and so on. So programming those machines manually, I would say in many cases it's even not possible. Yes, so the best way would be to program it into CAM software. All right, and I would say this is my favorite slide, where I can freely say that SolidCAM is the #1 and only Swiss type solution within the SolidWorks. If the customer itself already have a SolidWorks, we are the only CAM on the market that support the Swiss type within the SolidWorks. So I'm really happy to announce that. And let me then now start with this powerful module itself. And I will start basically with showing my favorite key features that SolidCAM has regarding to the Swiss type module. And I would say definitely that on the #1, it's integrated within not only the SolidWorks but also within the Autodesk Inventor. The software, it's equal on both systems. Yes, and therefore we have the power of associativity. Yes, we are always connected to the model. We always see the most updated model. We always build the toolpath and recalculate the new toolpath according to the model. Yes. The second is easy to use. Very important thing is on Swiss type on machining especially, is that software, it's easy to use and has the fast proven creation. I'll talk about that in the next slide, basically. And the third one, it's easy G code generation. So we want to be as easy as possible. We want to verify the toolpath within machine simulation, for which we have the viewports. I'll talk about that also later. We also support advanced kinematic. We support guide bush or guide bushless. We have powerful machine preview to see the machine position in any operation. We support any holder configuration for the machines. We have very powerful channel synchronization, which allows us to add a new workpiece. I will also explain it in live demonstration, what is adding a new workpiece. We do have supporting the superimposition, very, very important feature on the Swiss type machines. Axis pattern. and drive and axis sharing. On the bottom left, you will be able to find the link to the demonstration video, which I will not run on this demonstration. So you will get the presentation file, so you can just basically click on this video and enjoy the video. And yes, easy to use and fast program creation. I wanted to emphasize this slide because it is very important. I just had experience with one customer, and going from customer to customer, I realized that part programming on those machines can take about 1 day to 2 days, maybe sometimes even more, depends of part complexity, tools available, and so on. Yes, so the part programming time, it's very, very important. And building up the post processor with this at this customer, we completely make a part, set up the machine within the 1 hour. So this was incredible for the customer. He say, I never thought that anything can be done that fast. Yes. So later on, also I will show you the powers of associativity with the 3D model in order to get different palette of the similar model and so on and so on. Okay, so for me, the software and also for the Swiss type customer, the software must be very intuitive and good looking. Yes, it must be very easy to learn. It must have programming manuals, online help and support. So also online video tutorials. Yes, so this is one of the key features that I can say about our software. Also on the right side, I just mentioned few features that I'm really using with Swiss type module is that predefined MCOs that will come with the post processor. We do have a drag and drop templates, process template, and G-code generation. It's straightforward for a particular machine. Okay, so this is very, very important in order to achieve minimum programming time for a specific part and minimal setup time. Yes. All right, so there are some improvements in comparing to the previous version of the SolidCAM, and I will just say a few of those, and later on I will just demonstrate you. So the first improvement was the machine preview. We do have it in the tool table and the mounting. Very important, obviously, in the linear turrets, linear solder tools. You'll see everything right as it is on the machine itself. Then the updated preview to have updated machine. So in any moment, we can see where our machine will be located. We have predefined machine control operation, easy to use, straightforward. Then we have channel synchronization. And in this picture, I tried to show the differences between the previous versions and channel synchronization, how it is today, where the biggest change we implement is that more than 2 channels are possible. So we say unlimited number of the supported channels. We have split machining on both spindles, so the feature that I mentioned before also. So basically you can split the program anywhere where you want in order to get continuous machining on the machine, yes. We have the smart clash control system. This system basically guides you towards the solution in channel synchronization, and it will prevent you to make an errors. So basically, if you synchronize some of the operations which physically it is not possible to be done that way on the machine, you will not be allowed to generate either G-code or to simulate it. As you can see on this picture, you can see that there is thread squares on the particular elements of this channel synchronization, which is directing to the another channel what is wrong. Also, there's messages about this, but you can see here on the bottom that the simulation is kind of grayed out together with the G-code return, which means that you cannot simply, in this state of the channel synchronization, you cannot simulate or either generate the G-code. So this is big improvements that I would like to say in this presentation. The superimposition mode control. SolidCAM support 3 different types of superimposition, very crucial. One of the examples that I put over here is the when we have doing the cutoff, the machine must go in the state of the axis synchronization. So there is also the simultaneously superimposition. In this case, I just used a different machine, not the switch type 1, but you can obviously see the function capability on in this example. Yes. Then we do have an axis patterns. Most of the people ask me why we need axis patterns. So we never need these features on our machines. I would say on most of the regular military machines, 2 channels, 2 turrets, the axis pattern is no needed. But on the switch type machines, many machines are built in that way that have the tools on the channel 1. And for some reason, in order to minimize the cycle time, you want to use those tools on another channel. This is not physically possible on many machines if you're not exchange the axis. Exchanging the axis in SolidCAM, we are doing it basically by axis pattern. And this is one of the things what you can do with the axis pattern. Another is to turn on and off the superimposition and so on. I'll try to show you those examples in the next couple of minutes. But of course, I would also leave some things and some features to be done in the future webinars with the real examples. Then we have axis and drive unit management, like a balance wrap in this case. Inside machine simulation, we improved the simulation. So basically now you can go to the view tab, and basically you can split the machining view into 2, 3, or 4 columns basically, and every of those areas basically can be different state of the machine simulation. So in one can be with the stock, another can be without the stock, then the third can be without housing, another can be with different angle, and so on. So this is very, very needful, and they all run in simultaneous. Yes. All right. What I want to show you now, it's the live demonstration. And in this example, I just use pretty much simple part. I would say standard switch type pod. One of the reasons why I choose this one, it's that I can show you the main functionality of the switch type, yes. But also in some future webinars, we'll try to go towards the more complex pods, showing you how to program the pod in SolidCAM, and some of the very, I would say, special features that are available on in Swiss type module. We'll also show you how to use that inside the SolidCAM. All right, so what I'm going to show you here is the tool table itself first. And over here, we do have a mounting. And this machine, and the reason why I show you the mounting itself is just to give you a little bit impression of how everything is very smooth, how much linear turrets there are on this machine. So we have basically, I'll just explain you all the tools that are available here. On the left side, we have a couple of turning tools, and this is called like left gang tool. Then we have a couple of the drill or milling tools on the left side, then 2 on the top one. Then we do have kind of B-axis over here that this machine also is 5-axis, sorry, the B-axis simultaneously, so it can use as simultaneously and also as an indexial. Then there is a turret with linear tools, and from the face, there are 2 also for the turning over here. And then we have the back tool post, we call it, that consists also of the turning and milling tools itself, together with the main spindle and the back spindle. I'll just jump to the very first cutoff tool, which if you select it, you will see that he's pre-highlighted. And it's very important that everything that you change inside the tool table, it will be dynamically shown in the preview itself. So if I try to click over here on the DZ, which is very important parameter that will be also presented in the future webinars, you can see that using the scroll wheel, I can basically put the position of my cutoff tool. And everything is lively presented over here. So very, very powerful, yes. All right, I would not save this. And I'll go to the setup itself. Basically, always on the Swiss type machines, the machining starts on the main spindle. So on the standard military machines, this can be on the main spindle, also it can be on the back spindle, yes. So now the question is why we do need a setup. The setup is very necessary to say what will be the machining length. In this way, we can basically position which will be the machining length or where the chucker will clamp the part in order to start the machining. That number itself will be later on generated inside the G code. Now, for all of you that may be asking, you will get basically this part together with a presentation itself with machine simulation. If you are interested into getting also the post-processor for the G code output, please contact your local dealer for such a thing. Okay. Okay. The next thing, I would just like to show you one very nice feature here. Let's say that I have here. Let's say not this one, but let me use this one. Is it 36? Yeah, why not? So the machine preview. The machine preview inside operation will always show you the machine and the state before the machining, yes, if you calculated the operation. If you're generating operation from the beginning, then it will basically show you where the machine state is before the machining, yes, or where machine was in the latest position, yes. What I want to show you here is that here we are using the T number 7 in this case, yes. If I want to change the tool itself, I can just change it. And in this case, I don't want to use the tool on the left over here, this one, but instead I would just like to use the tool 18 over here. And the reason why I'm showing you this is that you don't need to change anything, either the submachine or it's basically you just select the tool, you just hit and calculate. Operation is calculated. You can go back into operation itself and click on the machine preview. What you can note here, I'll just move it to the right, is that machine preview changed its last, or let's say beginning of the operation. So its position, it's changed to that state. So you can everything see if you collide with anything or you have potential dangerous for something, you can actually avoid it before running the simulation or generating a G code. All right, this is for the milling, let's say. Let's go towards, over here I have one operation here that is the simple face turning that is on the back spindle. And what is very important for our model is that we have a capability to run the G code for the turning in X positive and X negative. Let me just again jump to the machine preview. Okay, and over here I have the left hand tool, and as you can see here, the code and system, the tool attacks basically the part itself from the negative side. This is very important for this particular machine, especially if you have some very long tool on another station that can lead the back spindle to very close position and hit that tool. So usually the customers in this case use the negative output in order to prevent such a thing. The same is happening for the milling tools, and I want to show you that as well. I will show you here one operation that is for the machining this hexagon on the back side. And as you can see here, I'll just again open the machine preview. Right. As you can see, in this case, the tool is attacking the part from the positive X direction. But many times, as you can see in this case, the part release position is pretty close over here, especially if we use the T24, it will be in the collision state, yes? So in these situations, we can basically go from X plus to the CX minus, and switching to that one, you can dynamically see the change that now the tool will have approach from the basically negative side over here. All right, two more things that I wanted to show over here. It's the MCOs, prepared operations or the templates with parameters that is minimum required in order to perform some action. In this case, I'm using it for pre-positioning for the cutoff. In this case, I have the cutoff position. I again use the machine preview. Okay, and as you can see here, the state of the machine is where it left after this operation over here. But opening this machine control operation and clicking on any of those parameters basically will change the state of the machining, and this is what will be actually also simulated in machine simulation. As you can see, this is the correct cutting position for this part. And the last, maybe MCO, I will show you also later on. Maybe not the last, I will show you also the pre-positioning over here. I'll go to the parameters, open the preview, and here we have, let me just orientate the machine correctly. We have the back spindle in the pre-clamping. Then we have rapid pre-position. I want to be exactly 5 mm in front of the part. Everything is very dynamic. I really like that. Then we have the clamp position that is defined as a setup location, also defined at the beginning of the project. So I'll just basically click on that, and SolidCAM automatically knows where the part must be clamped. And also another MCO that I would like to show is the part eject. We can simulate that as well. We can go to the machine preview. Usually the part length on Swiss type can be various, so this is very important that it is also variable, that where is the part release position. So I'll just click over here, and you can see the state of the machine before the releasing. I can just go over here and change its position to something else. I can change with the wheel again, mouse wheel, and I say, okay, this is 70. I think this is pretty safe position. It's closer, but it's pretty much good. I'll click OK, and it's done. Okay, let's just jump to the setup, and I want to show the channel synchronization. Channel synchronization can be assessed through the setup itself, doing a right click in channel synchronization, or you can also find it in the tabs over here, channel synchronization. Probably on your PC, it will be located over here. Basically, the channel synchronization, I'll just jump into it. It looks like this, okay? By default, if I remove all the channel synchronization labels and go with as it is in the CAM tree order, you will know that I can simulate and generate a G code. Now, in order to get the state where I have the continuous machining on the Swiss type, you need to use add a new workpiece function, in which case this is gray because it didn't click on where I want to actually to continue to have that. So I will click on the very first operation on back spindle. I can do a right click over here and add a new workpiece, or you can simply just click it over here. So I'll use this function over here. And now the case is either I can remove this weight mark and delete the synchronization label, or I can just select those operations and just drag it over here. So I'll choose the shorter way, and here it is. I have the total machining time over here, which is obviously like twice as shorter than the one if you go regularly from main spindle to the back spindle. And also this is very powerful features that I like to show and to present, like undo and redo buttons. All right, and there will be much more, but I will leave it for the future webinars. And now I would like to show you the power of associativity with a 3D model. And as you can see, this is the all toolpaths available on this part. Okay, and what I'm going to do here, I'll just turn off the toolpath, and I'll click on the model, and I'll just edit the part. As you can see, we didn't left the environment of the SolidWorks. We are in the part design, and in this case, you can see all the features of the SolidWorks. And I'll just change this model completely. So I'll just say, okay, let me go in the front. And one of the crucial, more critical things in the associativity is the length of the part. In this case, we have the part length of the 54, and the work offset over here on the back side, it's in this point over here. So let's see what SolidCAM will do if I try to change the length. I'll change it to 58, maybe this to, I don't know, 12, maybe 14, doesn't matter in this case. Let's go to the 42 here, maybe 28 here. Let's change the diameter, also this to 25 or so. I think this is pretty much fine. As you can see here, the work offset, it's still in the same position. Our stock and target envelope, it's completely different now. As you can see, it's not matching at all. And let me try to change also a few more things here. I'll just change depth of this to something like 12, and this one to like 10, so it's more deeper there. I can change the width over here, but I think this is completely fine. And here, this star means that this part is not saved, so I'll use Control S in order to save it. And I can just leave the pod. And by default, if I go to the SolidCAM settings, you can note here we have a synchronization, and my settings, it's basically turned off to check this synchronization as always, or asked before synchronization and it checked. Now for this demonstration, I turned that off. I want to show you what actually is going on in the background. So what I'm going to do here, I'll do right click on the CAM part itself, and I'll check the synchronization. So what the SolidCAM will check is that all elements that are in CAM tree is synchronized with the actual 3D model. And as you can see, the main things are coordinate system, the stock and target is changed, and every operation over here is changed now and modified, yes? So I will just do a right click over here and synchronize it. So I can now go through the coordinate system. It goes then to the target stock, building a new envelope, parsing the 3D model, and the last stage, by the way, all those steps, as I said, it can be automatically, yes? So what I'm going to do, as you can see, all the operations are now not calculated. I can just go right click, recalculate it, and we have completely new toolpaths. We have more down steps over here, more down steps over here, more down steps there, depending of how much down steps you left on inside operation, and completely new part is done. Generating G code has never been easier, so just generate the G code and generate. Now you have completely new G code for the both of the channels in a minute. Okay, sorry, not in a minute, in the, yeah, let's say in the minute after you change the 3D design. So this is the power of associativity. So many Swiss type customers will say that, you know, usually what they will do, they'll find some G code that they already built before, something similar, they will take it and then we'll start to modify that one. In SolidCAM, you don't have to do that. You just simply take the 3D model, you can change the reference model, leave the old operations, assign the geometry, recalculate operations, and it's done. And the last stage of this presentation is the simulation itself. I will just run first the solid verify, just pretty much roughly and quickly. Just to give you a small overview, what are the solids that are basically machined over here. Then we will just jump to the machine simulation and showing you the viewports. And with that, I will finish the demo presentation. Yes. So this is Solid Verify for a completely new part. Yes. And for this model, I'll just jump to the machine simulation. All operations will be sent to machine simulation module, and your particular machine that you selected on the beginning of the process will be loaded. Also, very important thing to say, moving from machine to machine has never been easier. You just select your particular machine, change to another machine. Of course, there are limitations in this. Not every machine have the same amount of the tools, also the turrets, but we'll make sure that we get the maximum that is possible in order to synchronize all the operations that on the Swiss type. Yes, pardon. One of the reasons why it looks too slow at my side is I realized that I have a very old graphic card display, so and your PC will run much better and faster. All right, so I'll go to the move list and I'll just load inside the setup. I'll just run the simulation itself so you can just enjoy it a little bit. So as you can see, all the tools are visible here. All are presented the same as it was in machine preview. The ball stocks are in ball spindles. Yes, and complete machining is done. Also, C-axis over here with a positive, also with a negative, and so on. I hope you enjoyed this. Let me go back to the presentation itself. A few more things I want to say. So today we can say, yes, we can. We do support the Swiss type. And behind us, we already work with many of our existing customers, make a lot of parts, prepare a lot of machines. And just a few slides are basically just the results of what we are capable of. We don't have the limits with a kinematic. We go really in details to make sure that all is well simulated. Yes, of course, we are not, depends from machine to machine. Sometimes we found that some machine, we don't have the housing or something like that. Of course, here the extra job is done to satisfy these customers. Yes. And I would just like to mention also one thing for the citizen in Technology Center in Germany, in Schramberg. We do have the Citizen D25. This machine is the latest machine by this machine brand, is the most complex with B-axis simultaneously with a lot of turrets over here. And we start developing post-processor for this machine. And on the right side, also on the left side, you can see, I would just like to show you the progress on this machine. Yes, so it's still not finished, but just to show you the differences between the real machine and the machine simulation itself. And this was one of the first screenshot with the first part that was machined on this machine. Behind all the scenes is the great post-processor team who is building this very complex and advanced Swiss type machines. We don't have any limits in building any of the machines. Yes, So we are really proud of it. We are working on this with this team. Also, this is one of the pictures that it's taken from exactly from the Schrumberg itself, from the training of this team. And last but not least is the one of the very few questions that actually I get also in the support channel is what are the minimum models that I need for running this switch type. So on the left side, I just put the machine that you already seen before. It has the full 5-axis capabilities, and also it is simultaneously B-axis. But for the minimal, even for this machine, you just need 2.5D milling, turning, machine simulation, and the switch type module. The switch type module itself includes the multi-tart synchronization itself. Okay, so I'm saying this is the minimal in order to run the switch type. Yes, I would always recommend to have with this HSS, HSR, and 4-axis simultaneously. Okay, and if your machine also have the B-axis, I will definitely put also the simultaneously 5-axis, and I'm machining 2D. And the last slide, it's the bonus. I would just like to present you the new Milton brochure that we just released in on Orlando this year. For all of you who never heard about this brochure, it is available. If you are looking for it, please contact your local dealer for it. Maybe you'll find it also in your local language. Okay, if you are interested to see that right now, you can basically do that clicking on the link in this presentation. So over here, you have a link towards that. So you just click it and it will guide you there. So just use this opportunity to just jump to there. Built-in brochure. It is in this form, so you can basically open it and enjoy it. Okay. So I'll just show a couple of the pictures. Okay. If you want to zoom in somewhere, you just use the double left click on any of the page, and it will open and show you in more higher quality. I hope you enjoy to this very first webinar in this webinar series. The next 3 webinars will be in this series will be the webinars about part programming, real parts, and how to program it basically from the scratch. I hope you all enjoy. I'll just check now if there is any other questions. Let me try to open it. Okay. Yeah, there's no, I see there is no questions here. And thank you all for your attention, and see you in the next webinars.